Now we will see assembler directives. Now basically what is assembler? So generally what happens when we write our program, then we write our program in a editor. Right? We write our program in an editor, and from this editor we generate one ASM file, assembly language file, with the extension .asm. This is assembly language file. Now once this file is generated, you can give some name to the file and .asm. For example, we will take for example x, y, z is the name of the file .asm. So this is an assembly language file. Now this file, whatever mnemonics or opcode we have used, so we will use those mnemonics to write our program in the editor, and when we save this program, then we save it with the extension .asm. So this .asm file will be generated. Now after the generation of ASM file, now this file will be passed through a software, and that is called as assembler. That is called as assembler. So basically this is our source file. This is our source file. .asm is our source file. And now this source file will be passed through assembler, and this assembler will generate an object file. Object file. So object file will have an extension obj. Name of the file will remain same, x, y, z .obj. So this object file is in the form of binary value, right? So this is basically binary file. But in this binary file, still it is not, the memory locations are not assigned. Only thing is, what is the binary code of particular opcode. For example, if we have written add AL, BL. If this instruction we have written in ASM file, .asm file, right? Now in object file, what is the binary code of this instruction? That will be there in object file. Binary code. But this binary code is stored in which particular memory location of our code memory or of our ROM. That information is not there in object file, right? So this file is, you cannot execute this file because it is not mentioned that whatever binary code is required for your program, at which particular memory location in the code memory it will be stored. So now this object file is to be passed through another program that is called as linker. Linker/locator. Right? So basically there are two programs. One is linker, one is locator. A linker, what it will do? If in our some project we are having more than one object files, right? Suppose there are 2 and 3 object files are there. So linker will link those files into one file. And locator will assign the memory locations of your code memory to the binary code. So locator will assign the binary location, the memory locations to our program, right? Where exactly these programs has to be written. And finally this linker and locator, it will generate exe file, right? Executable file. And this file and this file will be used to execute our program. So basically the purpose of assembler is to convert our assembly level program into binary code. And assembler directives. So there are few keywords which gives the direction to the assembler that do this or do this, right? So what assembler has to do? So to give the information to the assembler, we have to use few directives. So the main purpose of directive is main purpose of directives. Now suppose this is the memory which we have attached with our microprocessor. This is our memory. Now in this total memory, which particular section of the memory will act as code memory, which particular section will act as data memory or extra segment memory or stack segment memory. So all these allocation of the memory will be taken care by assembler directives. So first work is it allocates memory to code segment area, data segment area, stack segment area and extra segment area, right? So it will allocate, okay, this is the section of my code segment and this much memory section is stack segment, this much memory segment is my data segment and this much memory segment is extra segment. So it will allocate, right, by itself. Now the second purpose of this assembler directive is it allocates offset address to our data. Now suppose in data segment, this is our data segment. In data segment we are having two numbers, two 8-bit numbers, and suppose these numbers are here. These numbers are here. This is our first number and this is our second number. So now what is the offset address? What is the offset address of my first number? What is the offset address of my second number? So what are the offset address of our data? So that offset address will also assigned by assembler directives. So these are main purpose of the assembler directive. So now we will see what are various assembler directives. Now one assembler directive is DB. The meaning of this assembler directive is define byte. So whenever we use DB assembler directive, then it will assign a memory location in the memory for the byte, right? If we are using 1 byte in our program, then it will allocate 1 memory location for that byte. And if we are using 2 bytes in our program, then it will allocate 2 memory locations. So the allocation of the memory to the bytes will be done by DB, right? And the example how we will use this in our program like this. Suppose number 1. Number 1 is the name we have given to our some data. Then DB, and here we have written the value. What is our data? Suppose data is 34H. So here we have used DB directive, defined by directive. So now what will happen with this directive? This particular statement will inform the assembler that in our program the programmer is going to use 1 byte. Please assign the offset address of that byte and store the value 34H at that offset address. So it will inform the assembler. So automatically assembler, whatever memory locations are available there in the memory, so it will allocate one offset memory location to this byte 34H and it will load that value, right? For example, suppose this is our memory area, right? And in this segment, suppose let us assume this is our data segment. This is data segment. So now now in this data segment the offset addresses are from location 000H to FFFH, because the data segment will be of 64 KB. So there are total 64 KB means 65,536 locations. So in data segment there are 65,536 locations. So out of these locations, the assembler will assign one memory location, one offset location for this data, right? So what it will assign, which location it will assign, it totally depends upon the assembler and whatever memories are available. So automatically it will assign. Suppose our assembler assigns location 0000H, right? This 0000H to our this data. So and at this location it will store H also, right? There may be chance that in some program it will assign some other offset address to this data. So at that offset address it will load this data 34H. Now another category of this defined byte is one more thing. So whatever offset address is assigned, that offset address we can use in our program by using this variable number1. Now another form is suppose number is the name we have given, defined byte 34H, 49H, 3AH. So now in this case, if we use this statement in our program, then this defined byte directive, it will assign the three memory locations for 3 byte of data, right? It will assign some offset address, and at those offset address it will load 34H, 49H and 3AH, right? So while assigning the offset address, what this assembler will do, it will first assign the first offset address to first byte, and the next offset address will be utilized for next byte, and then after that next offset address will be assigned for next byte, right? Suppose our assembler had assigned the offset address of 1013H, this offset address to our first byte, right? So now what will happen in our data segment area, somewhere in the data segment where the offset address 1013 lies. Suppose this is 1013H. At this offset address, it will store this data, right? 34H. Then at the next offset address, that is 1014H, that is the next offset address. At that offset address, it will store the immediately next number which we have written in this statement. So here 49H. Then the third number 3AH will be stored at next offset address, that is 1015H. So here it will assign data 3AH. So basically by using DB directive, we are assigning the offset address to our data. Now another form of this DB directive is number DB question mark. Now suppose you just think about a situation. If we have written one program, in that program we want to add suppose 3 numbers, right? Then after the addition of the 3 numbers, we want to store our result somewhere in the memory, right? So in this particular case, we have taken these 3 numbers, so you may get one particular result. If suppose if I change these numbers, right, then I may get some different result. So here this directive, which ultimately in our program I am going to use to store my result. So this directive will reserve one memory location for 1 byte. But what should be stored at byte, that is not defined. Question mark means nothing should be stored at that particular location, because in the program some result may be generated and programmer will store that result at that location, right? So what will happen? So some offset address, one memory location will be reserved to store this number, okay? And whatever result is calculated during the program, that can be stored by the programmer there. Now, so another is DW. This means this is directive used for define word, right? So this directive will assign the memory location for a word, right? Word means for 2 bytes. So for 2 bytes, if we use directive DW, then 2 memory locations will be reserved, right, for that word. Because we know that at one location, see here at one location you can store only 1 byte. So if we are going to store a word, then we require 2 memory locations. So with this directive, 2 memory locations will be reserved. For example, number DW 3295H. So now this is my 16-bit number. 3295H is a 16-bit number. So to store this 16-bit number, we require 2 memory locations. So here if we are using this directive, then 2 memory locations will be reserved, and this is your lower 8 bits, right? And this is our higher 8 bits. So lower 8 bits will be stored at lower offset address, and higher 8 bits will be stored at higher offset address, right? And our assembler will assign whatever memory locations are available. So assign the two memory locations for this word 3295. So let us assume assembler has assigned two memory locations 0000 and 0001H. These two locations it has assigned for this number, right? Which is a word. So what will happen? 95H will be stored at lower offset address, that is 0000H. So here 95 will be stored, and higher 8 bit which is 32 will be stored at higher offset address. So 32 will be stored at higher offset address. So in this way numbers can be stored. Another example is number defined byte 3295H, 9AF3H, 34A0H. So here this statement will inform the assembler that reserve few memory locations for three words. So this is first word, this is second word, and this is third word, right? So reserve memory locations for my three words. So suppose our assembler has decided that to store the locations of these three words, the first offset address will be 0010H. From here it will it will reserve the memory location. So how many memory locations are required? For first word we require two memory locations. Then two memory locations are required for second word, and for third word two memory locations. So total 6 memory locations are required. Since assembler is reserving the memory from location offset address 0010, so we require 0011 also, 0012, 0013H, 0014H, 1, 2, 3, 4, 5, and 0015H. So these 6 memory locations will be reserved for these three words, right? And the first word will be stored at lower two locations, right? So this is the first word, and lower 8 bit is 95. So 95 will be stored at lower offset address 95H. Higher 8 bit is 32, will be stored at next location 32H. Then the second word will be stored from offset address 0012. So in 0012, lower 8 bit of our number is F3. This will be stored. Higher 8 bits will be stored at, that is 9A. It will be stored at 0013. Now the third number will be stored from at the next two locations. So in the third number, lower 8 bit is A0. First it will be stored, then higher 8 bit will be stored. In this way, automatically in the memory these numbers will be stored, and in our program we can utilize those numbers in our program. Now another example is number define word DUP and 5, 3, 4, 9. Okay, regarding this, here basically it is used to duplicate the numbers, right? Same numbers will be stored at many locations. So regarding this, we will see when we will utilize this in our program, right? So up to here we have seen the defined byte and defined word. Now there is a directive assume. So assume directive is used to allocate the memory location for our code segment memory area, data segment memory area, stack segment memory area, and extra segment memory area. So here the format for this is to assigning the suppose this is our data segment, right? So we must assign some address in data segment register. This is our data segment register, right? We must store some 16-bit address in data segment register. Then only the starting location of my data segment will be initialized. So to initialize that our data segment, we have to use assume directive. So the syntax for this is assume ds colon give some name. Suppose I have given the name data. So whenever in our program I will use this word data, then automatically the memory for my data segment will be allocated by the assembler. So there are 4 forms of the assume instruction, assume directive. Assume CS, this is for code segment. You can give any name. Suppose we have given code. We shall give the name to the directive which we can understand why we are using these directives. Another is assume SS for my stack area. And another format is assume ES for my extra segment area, right? So these are the 4 format of assume. Now whenever we have created some data segment, then we have to end that. For that we have to use another directive, that is end S. So end S means this S indicates end segment, right? So we have to use this directive end S. And before this directive end S, you have to mention the name of the segment, right? For example, data end S, right? So with this, my data segment area will end. Or code end S. So with this, my the area where I have written the code of my program, that will end. So these are few directives, and some more directives are there. But when we will discuss about those directives when as and when it is required. So now what I will do, I will write a small program just with the help of directive to transfer one number from one memory location to another memory location, right? So suppose what I want, this is my one number, some first number, and this number is stored at some offset area in the memory, and I want to transfer this number to new memory location. So this program I will write first with the help of directives. So to write the program, first we will write assume, because we have to first create the data segment area where we will store our data, and our code segment area where we will store our code. So assume CS colon code comma. So in the same line we can write this by writing the comma, ds colon data. Now data segment. Now for my data segment I will write the program. I will write the directives. So what are my data? So here I will use, suppose N1 DB 34H. So with this, one offset address will be selected in our data segment, and at that offset this data 34 will be stored, and we can call that offset address with the name N1. So let us assume this is my offset address, right? Offset address for N1. Now, since I want to transfer this number to new offset address, right? Offset address, right? And I will call this by another name N2. So now I will create another offset address by the name N2 DB, and here I will put question mark. So now what will happen? My assembler will fix two memory locations. One memory location will be fixed first, and at that location number 34 will be stored. So at this location number 34H will be stored. Now another memory location will be fixed for my another variable N2, and whatever is to be stored here, it is not defined in this by directive, because when I will write the program, then during the program data will be transferred to at this location, right? So after this I will end now this my data segment. So to end this, write data end S. Now I have to write my program code. So code has to be written in code area of the memory. So this is my data segment, right? Here data will be stored. Now suppose in this memory, this area is defined for my code segment, right? So now whatever instruction I will write to transfer this number from this place to new place, so that code will be stored in code memory, right? And exactly where it will be stored, it will be defined by directive now. So now I will write code segment. That here, when we start our program, then first you have to write one label start, right? After this I will write instruction move AX, comma, now here I write DS. Here I write data, and after this move DS, comma, AX. Now what will happen? Since already we have used this directive assume DS, comma, data, so our assembler has assigned some 16-bit address to my data segment, to my DS register, right? Some 16-bit address has to be assigned to DS register. And what is that 16-bit address? That has been defined by the assembler, that we have to load in data segment register. So for that I have written instruction move AX, comma, data. So now here this data, it will store the 16-bit address of my DS register, data segment register in AX, right? And then from AX I will transfer it to DS. So that DS has been assigned, has been initialized. Now move SI, comma, offset N1. So now with this instruction, what I am trying to do, whatever the offset address of my data, right? Whatever offset address has been fixed by the assembler, so that offset address I have to load in SI register, right? Since I have used the here this word N1, right? So N1 defines the offset address of my this byte 34. So here with the instruction move SI, comma, offset N1, the offset address, this address, right? This address will be stored in SI. Let us assume it is 0000H. Our assembler has defined the offset address 000H for my data 34. So what will happen with this instruction? 000H will be stored in SI register. Then move DI, comma, offset N2. Now where we want to transfer this data, the offset address of that memory. So that offset address of that memory I want to store in DI register. So with this instruction what will happen? N2 is used in this directive, right? So this directive will reserve one memory location for 1 byte, and the offset address of that memory location you can access by using name N2. So here I have used this offset address of N2, right? So it will be stored in DI. Now simply I have to bring first number in AL register first. So for that I will write instruction move AL, comma, within bracket SI. So now in this, what will happen? Whatever is the value of SI, that is the offset address of one data. That data will be moved in AL register, right? Already in SI, in this instruction, we have loaded the offset address of our data, right? So our data, which is 34, it will be moved in AL register, right? Now I will write instruction move within bracket DI, comma, AL. So now whatever is there in AL, so in AL we have our data 34 which we want to transfer. So that data will be moved to the memory whose address is defined by DI. So in DI, what we have? In DI we have the offset address which is reserved for our transfer of the data. So now data will be moved to this offset address, and here 34H will be moved, right? And in the last, we can start our program by int 21, right? So basically int 21 is a software interrupt. So when we will discuss about the interrupt, at that time we will discuss about the int. But right now you just understand with int 21 program will stop, right? And after this, you first end your code segment, right? So for that, first write the word code and then end S, right? Just like here, data and S, code and S. Now after this, you end your this label. So for that, you write first end, then start. And in the last, you write end. So the last end will inform the assembler that there is now no assembly level code after this line, right? So this will inform the assembler. Whatever you will write after end, the assembler will not consider those things as a code. So you have to write everything before this end. So this is the full program. Now in the software, we will see how exactly this code will be, we can use this code to perform the operation, right?